7.4 Day 2, we're looking at partial fractions. And so this lesson is going to focus on quadratics. The procedure used to solve for the constants a, b in examples 1 and 2 works well when the factors of the denominator are linear. When the denominator contains irreducible quadratic factors, a better process is to write the right side of the basic equation in polynomial form, equate the coefficients of like terms to form a system of equations, and solve the resulting system for the constants. Let's try this example here. Distinct linear and quadratic factors. We're going to write the partial fraction decomposition of 3x squared plus 4x plus 4 over x cubed plus 4x. So we want to factor the denominator. It's not improper, so we can leave it as it is. So let's factor the denominator. We can factor out an x. And we have x squared plus 4. So now we see this is different from the previous lesson because now we see that we have a linear and we have a quadratic that is irreducible. So this is how we write this. Let's write 3x squared plus 4x plus 4 over x times x squared plus 4. So then we write the linear, the x over a constant, or a, the constant over that linear, plus a linear bx plus c over the quadratic. Okay, so this is a quadratic here. So this is the partial fraction form that you write. And then we solve it like we did previously, meaning we're going to multiply by the LCD in order to get our basic equation. So this is a times x squared plus 4 plus bx plus c times x. So now when you expand the basic equation and collect like terms, so we want to write it in polynomial form. So let's work with this right side. So this is just going to be ax squared plus 4a plus bx squared plus cx. And then to collect like terms, we have x squares here. So let's put those together. So we're going to write this as a plus b x squared plus cx plus 4a. So we're writing in polynomial form. We have 3x squared plus 4x plus 4 on this side here. So now what we're going to do is we're going to use the fact that two polynomials are equal if and only if the coefficients of like terms are equal, and that's going to help us write a system of linear equations. So what I'm saying is we're going to take this x squared and equate it to the x squared value, equate the x with the x, and then our constant with the constant. So let's do that. So we're going to write a plus b equals our x squared of 3. Then we have our c equals the x, same as the x value, 4. And then we also have the constant 4a equals 4. So now we solve. So we know what that c is 4. 4a equals 4. So therefore we know that a will equal 1. So c is 4, a is 1. And let's solve for b. So we have a plus b equals 3, or 1 plus b equals 3, or b equals 2. So this one was fairly nice. And so we plug it in. And so we have 3x squared plus 4x plus 4 over the x times x squared plus 4. And that equals a, which is 1 over x, plus b, which is 2x, plus c, 4, is x squared plus 4. So you try. Write the partial fraction decomposition of 2x squared minus 5 over x cubed plus x. So trying this out, the denominator factors to x times x squared plus 1. Then you have this polynomial, 2x squared minus 5 equals ax squared plus a plus bx squared plus cx. Then you equate the x squares, the x values, and the constants together, and you find that a is -5, b is 7, and c is 0. Then you plug it in.